Good afternoon, everybody. Let's start what I will call the best session of the afternoon. I might be a little biased. I'm Mariangeles Arce. I'm the executive director of the Center of Systematic Biology and Evolution here at the Academy. That's the center that hosts all of our biodiversity collections. I'm going to moderate the roundtable around academic collections highlights. Our first presenter is Elizabeth Hyde. She's an associate dean of the College of Liberal Arts and professor of history at Kean University, and she's also the author of Cultivated Power, Flowers, Culture, and Politics in the Reign of Louis XIV contributor, and she's a contributor to a cultural history of gardens in the Renaissance. She's going to be talking about André Michaux and communities of practice and plants.
Thank you all for staying through the duration of the afternoon. So the botanical mission of André Michaux, a French botanist who, fresh from an official botanical mission to Persia, was dispatched in late 1785 to the United States to study and collect North American specimens. His mission was the culmination of an aggressive attempt on the part of French botanists at the Jardin du Roi in Paris and ministers in the French government to acquire knowledge about and specimens of North American plants and trees that might find a happy culture in France. The most enterprising aspect of French efforts at colonial botany, Michaux systematically explored North America and the Mid-Atlantic and the South in particular, establishing nurseries in Hoboken, New Jersey, and in Charleston, South Carolina, where plants would be gathered before shipment back to France. He sent tens of thousands of trees, seeds, and even birds back to France, along with his observations on their cultivation and uses. These could thus furnish not only the highly desired aesthetic specimens for the 18th century landscape garden, but also the intellectual capital of the growing botanical knowledge and much needed timber for shipbuilding, each of which better positioned France in the global 18th century. In the 10 years that the French botanist André Michaux spent exploring North American forests on behalf of the French monarchy and then Republican government, documenting the flora and fauna, he carried out the labor of making natural history. By the very words that he recorded in his journals, he botanized, and here's an image, rather blurry, but an image of his journal, which is one of the wonderful things at the American Philosophical Society. But the very words recorded in this journal, labor that for him entailed the observation, collection, preservation, organization, cultivation, description, naming, and sharing of the plants, trees especially, that were the subject of his mission. He cut a solitary figure pushing his way through the Appalachian wilderness, and posthumous celebrations of his botanical contributions to the nation of France and the international world of science really presented him as the Indiana Jones of the botanical world of the 18th century. He was memorialized by a French naturalist writing, "I will not stop to describe," he wrote disingenuously, "the dangers which our traveler ran in these solitudes, where he had constantly to climb the sharp rocks, wade through torrents, walk on the bodies, walk on the bodies of trees that sank under his steps, where frightful obscurity," having a little bit of a technical problem here, sorry, where technical obscurity produced by the thickness of the brush and the trees united their branches, making it all the more difficult for him to pass through this wilderness. Deleuze painted this picture of the botanist as hero. He shot bears in Appalachia. He battled alligators in Florida. He lost horse after horse as he attempted to carry out his work. The journals narrate really as much of a story of suffering as of heroism, but the image is of this solitary hero traipsing through the woods. All the while, he recorded his actions methodically, tersely, sparely in the journals that he kept, shown again here. And our knowledge of his botanical labors are really supplemented, or in this journal, but supplemented by the letters that he wrote to his mentors and superiors in France. Even taking those letters into consideration, Michaux's communications, frustratingly for the historian, might be characterized as the opposite of effusive. So much so that one rather well-known modern scholar of natural history said to me, "I don't work on figures like that." But a close reading, Michaux's journal, terse and spare as it is, reveals that while he botanized in the geographical periphery of the scientific community, he conducted this labor from within a cosmopolitan and diverse world. He cultivated and relied upon complex networks of governments, institutions, amateurs, colonists, Native Americans, and enslaved laborers in connecting the metropole to the colonial periphery, the scientific and institutional apparatuses to the collectors in the field, the bookish to the laborer, in order to gather, grow, and aggregate knowledge of plants from around the globe. In his journal, Michaux documents his botanical fieldwork, as I've said, with the verb herboriser. To the 1694 edition of the Dictionnaire de l'Académie Française defines herboriser as to go into the fields, into the woods or gardens in order to know the herbs and cut them. But by the 1762 fourth edition of the dictionary, the definition had become more specific with regard to the purpose of botanizing or herborizing. It is to go into the fields, into the woods, and into the gardens to search for herbs and plants, either out of curiosity or in order to identify their appropriate medicinal uses. This evolving definition is, of course, closer to what Michaux was doing. Herborizing or botanizing meant to him visiting locations, observing plants there, identifying them, recording them in his journal. But it was more than the sum of these activities. In a particular passage recorded in Tennessee, he wrote, saw a new genre of plant designated by Linnaeus as Podophyllum diphyllium and discovered there some years ago in Virginia. This plant is less rare in the fertile terrain of Kentucky and in the Cumberland region. You can find it in the environs of Knoxville as well. Dr. Barton gave it the name of Jeffersonia in his description that he gave to this plant after having seen it flower in the plants recorded in Philadelphia at the garden of the botanist Bartram. So here you have Michaux observing a plant that he already knew, and in identifying it, connecting it to the by now definitive Linnaean classification system, placing it geographically in North America, accounting for its scarcity, and reporting its history, part of which he had written in context of the larger scientific community. So here in Tennessee, he found an example of a plant first discovered in Virginia, given to the preeminent American botanist Bartram, who'd shown it to Benjamin Barton, who, among other things, was affiliated with the American Philosophical Society. So botanizing, herborizing, was therefore connecting a plant to a larger scientific community. It involved other practices as well, however, that Michaux describes in his journal. It involved the ordering of his collections. He reports in his journal periodically the days when he takes the time to organize the seeds and the samples that he collected, which make these wonderful, wonderful bundles that still survive in the French Museum of Natural History. He also engaged in writing in similar but more geopolitically commercial vein. When his botanizing took him again to Tennessee, Michaux personally wrote to William Blount, governor of the Western Territory, to report on his discoveries. In his journal, he reported that on the 2nd of March of this particular year, he took the occasion to write to Governor Blount. The writing that he was actually referring to was a letter about a tree that he discovered, which he was comparing to the saphoras found in China and Japan. This letter ended up in print, published in newspapers around the new United States. If this was a more popular form of communication of his work, he, of course, would go on to produce his History of American Oaks and his North American Flora, volumes of which, of course, are in the collection here in the American Philosophical Society. The dialogue that he engages in print and in person with the figures who end up featuring in his journal speak to the other key piece that he records, and that is the act of visiting. The act of visiting occurs again and again throughout his journal, but of course it's not meant as social visiting. Rather, his journal documents the encounters that he had with American botanists, of course, Barton and Bartram that we've already mentioned, members of the founders, Washington and Jefferson, for example, institutions, the American Philosophical Society, the Charleston Society of Library, the Charleston Agricultural Society, just to name a few. Though these visits, or through these visits rather, Michaux acquired and shared seeds. He accessed books, he cultivated networks, he built out networks of botanically curious that really stretched back and forth across the Atlantic. What this is just a very first draft of an attempt to map all these networks that can be reconstructed from his journals, and then of course the people with whom he interacted. And you'll see that it's a rather complex map that if we were live on the internet would be able to exploit some additional complexities. But you'll see that you find these incredible networks of labor that can be defined around Michaux himself. So here you see Michaux connected to the institutions with whom he interacted, with persons with whom he interacted, with persons with whom he exchanged seeds, just to name a few of the connections that this map reveals. The institutions highlighted here, and I've included commercial institutions, libraries, and of course institutions like the American Philosophical Society and the Jardin du Roi, for example, in Paris, and Kew Gardens in England. I'm also mapping the books that are at the center of these encounters, because you'll find that Michaux references the volumes that he carried with him into the field, but also the efforts that he made in seeking out books that he needed access to as he was moving through North America. Here you have a map of the seed recipients that are part, again, of this larger network. These seed recipients are documented, of course, in Michaux's journal, but then also in the archives of many of those who were recipients. One key piece that we have to consider is that as we build out these networks, as we build out the mapping of these relationships that constitute the world of natural history in the Revolutionary era, we have to take note that not all of the participants in the labor of doing natural history show up in these maps equally. As Michaux explored North America, he did so with the hired help of Native Americans and the purchased labor of enslaved Africans. Michaux recorded none of the names in his journals, but he did record the Native American plant names and usages that he came across, botanical knowledge likely gleaned from the Native American guides that he employed. Botanical knowledge and practices also come from the enslaved persons with whom he was associated, though they are harder to encounter in his journal. When Michaux returned to France, Michaux took one enslaved man, identified in later documents as Merlot, with him. This person, described as an apprentice gardener, accompanied Michaux as an assistant on his expedition to Madagascar. His status as free or enslaved in Madagascar is unclear, though it is believed that after Michaux's death, Merlot was sold back into slavery, though potentially freed again. Second really important piece of the labor that is essential to identify is the fact that in the Charleston Garden, where Michaux spent the majority of his time in North America, he purchased the garden to transform it not only into a nursery where specimens would be collected in order to send back to France, but also to transform it into a productive farm or plantation that would help defray the costs of his botanical explorations of the continent. He did create a productive farm. He added sheep, cows, and so forth to the growing nursery garden that was at times worked by as many as 24 enslaved Africans and African Americans. These networks then show that the work of the botanist was anything but solitary. It shows that rather André Michaux even when he was traipsing in solitude through the Appalachian forests, was tied to the cosmopolitan world of 18th century intellectual societies and botanical gardens, but also to the labor of those who were colonizing these new lands and the enslaved labor that was building this land economically. Thank you.
Thank you, Elizabeth. That was a very impressive network right there. Let's see if we can discuss a little more when we have time for the conversation. Now we're going to hear from Maria Zytaruk. She's a professor of English at the University of Calgary, and she's also the director of the Books Art Lab, an experiential learning space where students can make paper by hand, do letterpress printing, and bind books by hand. She's going to talk about laboring for seeds, declassifying 18th century seed packets.
Thanks very much. On 7 November 1796, William Hamilton, owner of the Woodlands estate on the Schuylkill River, wrote to the artist and naturalist William Bartram on some pressing botanical matters. I must beg the favor of you to make a sketch of the Senecio nova floribunda, as it now blooms in my hothouse. For this obligation, I will make you any compensation in my power. After this day, it cannot be done this season because its beauty is already on the decline. Anxious to capture the ephemeral blooms in his hothouse, Hamilton tries to entice Bartram with the following piece of botanical intelligence. I have in my hands near 100 colored plates, mostly of new plants, some of Botany Bay, which you ought not to lose the opportunity of viewing. They are immediately to be returned to the gentleman who left them here. If the lure of seeing illustrations associated with the Endeavour voyages was not sufficient to secure Bartram's attendance at Woodlands, Hamilton appeals to the latter's patriotism. This sketch would be for the honor of American gardening, as Europe is now claiming priority in cultivating Hamilton's Senecio under the name Senecio chrysanthemum. We have some idea of the scale of Hamilton's horticultural experiments from a diary entry by the South Carolina plantation owner, Charles Drayton, who visited Woodlands in 1806. This conservatory is said to be equal to any in Europe. It contains between 7,000 and 8,000 plants. Though the identity of the gentleman who lent Hamilton the Botany Bay botanical prints is unclear from the letter, Joseph Banks had commissioned copperplate engravings of plants collected on the Endeavour voyages, and it's possible that a hand-colored set of these was circulating by the end of the 18th century in America. The reputation of Woodlands as a site for horticultural experiments meant that botanical artists and collectors were just quite naturally drawn into its orbit. Plants and seeds with special provenance also flowed into Woodlands. When the first shipments of seeds arrived back from Lewis and Clark's expedition, Thomas Jefferson, at Hamilton's request, ensured that a box of seeds of the Missouri flora reached Woodlands. The American Philosophical Society also viewed Woodlands as the proper destination for a donation of sundry Asiatic plants made by William Roxburgh in May 1794, then curator of the Calcutta Botanic Garden. Previous scholars have relied principally on visitors' accounts and on a relatively small selection of extant letters to delineate such features of Woodlands as its place in practices of refinement, the American picturesque, and the history of American arboreta. My paper today, however, draws on a unique source of documentary evidence, which has really only recently come to light: 18th century seed packets. In 1992, Timothy Preston Long, an architect with the National Park Service and an expert on the architectural history of Woodlands, discovered about 200 seed packets above a plastered ceiling in an unfloored section of the attic while he was conducting a structural survey of the Woodlands mansion. The late Joel Fry, longtime curator of Bartram's Garden, produced initial transcriptions of these packets, and Bob Peck has also published some initial observations. The hexagonal packets, some of which still contain original seeds and plant material, are held here at the Academy. This packet gives the binomial name of the binomial Hibiscus hastatus, plant native to Tahiti, and Michaux is cited as the authority. Placing these fragile seed enclosures at the center of my inquiries, I explore what they have to tell us about three interrelated subjects. First, the day-to-day gardening practices at woodlands. Second, the history of packaging seeds for circulation and preservation. Third, the special status of these material objects, or beings, if we were to think in terms of indigenous relational frameworks, as they are now lodged in institutional repositories. There can be little doubt that the colored plates of new plants, which made their way to woodlands in 1796, are implicated in the extractive and violent colonial processes that underpin the botanical collections made by 18th century imperial powers. While the Botany Bay plants may have been new to Philadelphia's gardening elite, they had, of course, been long named and known by our Aboriginal communities in the Sydney region. At the micro level, the woodland seed packets repeat this kind of colonial erasure, even as Hamilton seeks to preserve and to cultivate these species. This difficult to decipher seed packet seems to have a Latin binomial. I've only been able to make out the second name, Falcatus, a tree species. The phrase, first word, second line, still haven't made that out, but plant among Cape of G Hope seeds, and you see Mr. Lyon at the bottom. John Lyon served as one of Hamilton's gardeners and spent many years himself collecting plants in the US states. And possibly this inscription is a set of sewing instructions from Hamilton to Lyon. It was in March 1771 that the Endeavour made botanical collections at the Cape of Good Hope. And so it seems that by a couple of decades later, Hamilton is creating his own colony of Good Hope plants back at Woodlands. And the packet's inscription all materializes this transit of seeds across the globe. Even were this packet not to be torn, its contents would to some degree remain illegible. Linnaean taxonomy overwrites the species' original names and uses. In preserving a seed and some plant material, that was enclosed in it, this packet also points to how such paper enclosures served as miniature herbaria. But whereas a full-size mounted herbarium specimen freezes a plant in bloom, seed packets occupy more than one temporal space. Seeds represent, even if not made legible in their inscriptions, these seed packets, the labor and cultivation decisions of past generations, and embed within them the potential to come alive in the future again. Now that once gardeners on an estate the size of Woodlands were expected to save seeds and to serve as custodians of such seed collections is evident in the Articles of Agreement signed by George Washington with his gardener David Cowan in January 1773. For a salary of £25 a year plus lodging and food, Cowan was to employ himself in grafting, budding, and pruning of fruit trees and vines, likewise in saving at proper seasons and in due order seeds of all kinds. The seeds that Cowan stewarded would have included some of the woodlands ones, as Hamilton was a regular supplier of large quantities of plant material to Mount Vernon during the 1780s. When Hamilton was away for some periods during that decade, he wrote to his secretary, Benjamin Smith, to remind his gardener, George Hilton, of his seed-related duties. Direct George to attend to the ripening of the seeds so as to save them. The woodlands packets are inscribed in a few different hands, and this likely reflects the fact that Hamilton had multiple gardeners in addition to Lyons and Hilton. In this seed packet, possibly we have sent by George from Jersey, 1803, articulated pods, and the very faint MIC for Michaux for an authority on one of the lines. This particular species from Jersey, the sensitive or Virginia joint vetch is now endangered. So because some of these packets are dated, they could potentially provide important biodiversity baseline information. These two packets show that this was to some extent it appears that this seed collection was a working collection. In the left packet, we can see a circle with possibly 2 dots in it. The right packet shows a circle, bottom line, a circle with 1 dot in it. It's difficult to know with certainty, but these notations may indicate the quantity of seeds remaining in the packet after the person was going back to them. Now, if one's gardeners were required to maintain an estate seed collection, it's worth considering what paper materials tended to be used to enclose seeds in the 18th century. The plant collector and physician John Fothergill shed some light on this question in a letter that he addressed to the botanist and seed supplier Humphrey Marshall of Pennsylvania in April 1771. I am economist enough to save the covers of my letters instead of throwing them into the fire. I give them to my gardener to wrap his seeds in. Some of them I have thrust into the empty box for the like purpose. Now, Hamilton seems to have observed almost the same economy as the Quaker Fothergill in his seed wrappers. And it's typical for the woodland packets to be made from stationer's paper, and I'm still working on trying to identify that watermark. And in other cases, he's reused manuscript material. In this case, it looks like a series of debts paid, debts collected. And in this case, we have, it looks like possibly a seed packet for the cotton seed cut down and made into a smaller packet. There is an organic circularity in handmade paper encasing these saved seeds. In the 18th century, it was the flax plant from which linen was spun, linen rags beaten and retted, formed the pulp out of which sheets of paper were cast. Now, this small selection of woodlands packets that I've discussed today speak to the ways in which seed saving formed a key archival practice by gardeners and plant collectors. Although the gathering of plants for herbarium specimens in bloom didn't usually coincide with the optimal time for gathering seeds, these were interrelated practices. And we know that Hamilton had developed quite an elaborate system for preserving dried specimens. So this collection was probably adjacent to his herbarium collection. Now, when we look at herbarium sheets today, and this is a sheet for a specimen at Harvard of the Sabal mexicana, it's exceptional in how it encapsulates the longer paper history of seed saving. At first glance, you have a usual sort of acid-free fragment packet there at the bottom. But inside that packet is this pre-printed seed packet that the Arnold was using to exchange its seeds. And inside that packet was this wrapped seed in a piece of paper, one ripe seed of the palmetto. So the fragment packets nested enclosures document the shift in seed collecting from a more private manuscript practice to a more institutional one standardized through print. The woodlands packets then urge us to consider what might be absent from the conserved herbarium sheets that we encounter today in institutional repositories. The printed precursors to the seed packets, institutional herbarium and arboreta, the woodlands packets also fill in gaps in our visual history of commercial seed packets. And here's just an example from Landreth and Sons in Philadelphia, which could use chromolithography by the end of the 19th century to advertise their seeds. Looking one final time at the woodlands packets, the seeds seem to embody a startling resilience. They appear to have already survived the disasters of fire, flood, and plagues of rodents. In fact, the nod marks on the packet suggest that at least some of the seeds were subject to further dispersal. Won't get into the details. At a time of climate emergency and when museums and archives are reckoning with the legacies of racism and colonialism in their holdings, these seeds with economy compel us to acknowledge these entangled practices and to imagine a different future. If in some ways these packets and their seeds have been overclassified, I hope that today by unfolding the contents of some of the woodlands packets, I've made the case for why we should attend to these liminal and often inscrutable objects, seeds. Thank you.
Thank you, Maria. Just as a reminder for everybody, after the session and the discussion, we're gonna head into the Dietrich Gallery and the complementary, like the adjacent reading library room. We can see some of the materials that have been discussed during this roundtable. Now we're gonna hear from Kelsey Manahan-Phelan. She is the Special Collections Librarian here at the Academy. Over the past 8 years, Kelsey has delved into the Academy libraries and archives collections, highlighting unique materials and crafting narratives that bring the story of the natural sciences to life. She's going to be talking today. Her talk is Don't Fear the Geaster, Ana Maria Jose, 1805 to 1853, Illustrations of British Mycology, 1847 to 55.
Thank you. So I have had the immense privilege to spend a lot of time with the Academy's library collections. And I try not to play favorites, but today I'd like to talk about one that I've probably spent the most time with, authored by one of the first female mycologists who attempted to eradicate the fear of fungi, which was very pervasive throughout Britain, Anna Maria Hussey. But before we can talk about Hussey's work, we'll first discuss the state of British mycology prior to the publication of her principal work, Illustrations of British Mycology. By the mid-19th century, the study of mycology lagged compared to the study of other areas of botany, and very few works illustrating the British fungi were available. While there was some mention of fungi in the various materia medica and the floras, there was no British work devoted solely to the fungi until the publication of James Bolton's A History of Funguses Growing About Halifax, published from 1788 to 1791. In 1797, James Sowerby began publishing colored figures of English fungi or mushrooms, intended as a supplement to his and James Edward Smith's English botany, which did not include fungi. The next work on the British fungi doesn't appear until 1823, with Robert K. Greville's Scottish Cryptogrammic Flora, likewise intended as a continuation of English botany. Finally, in 1836, the most comprehensive taxonomic overview of British fungi, authored by the Reverend Miles Joseph Berkeley, who is often referred to as the father of British mycology, appears as the 5th volume of William Jackson Hooker's conclusion of Smith's English Flora, in which in the preface of this volume, Hooker states that fungi must be acknowledged as the least understood of all of our British flora. The lack of understanding seems to be in part related to the kind of peculiar place that fungi occupied in British life. While you could very frequently find fungi in the markets and on the dining tables of the continent, the prevailing attitude of the British towards fungi was largely one of revulsion. The source of this discriminatory attitude towards fungi is difficult to trace. However, it's mostly described as a matter of ignorance, due to the difficulty of ascertaining the harmless and the escalent from the poisonous. And although the term fungophobia wasn't coined until 1887 in William Delisle Hay's textbook of British fungi, the sentiment was widely discussed. And regarding fungophobia, Hay says, if it were human, that is universal, one would be inclined to set it down as instinct, but it is not human, it is merely British. Caution towards fungi was not entirely unwarranted, as stories of accidental poisoning were not uncommon. There was a well-publicized case from 1799 in which a man in London who, walking around the fields in Hyde Park, he would often pick mushrooms for his family and accidentally picked something he thought was esculent, but was in fact likely psilocybe semolanciata, which induced hallucinogenic effects in his entire family. And you can see it illustrated here in figures 1, 2, and 3 on the left by Sowerby. He's actually also confused it with what they called at the time Agaricus semiglobata. So you can see even the experts often got confused. And the existing literature that would enable one to make such distinctions was lacking and largely inaccessible to non-botanists. And that's where Hussey enters. So Anna Maria Hussey was born Anna Maria Reed. She was the daughter of a clergyman and likely received an education typical of a young woman of her class. In 1831, she married Thomas John Hussey, rector of Hayes in Kent, and himself an astronomer. A diary of hers from a trip to Dover in 1836 shows that she was initially interested in geology, but she also began to become interested in botany during this trip, and her mycological work began no later than 1840. The Husseys were well acquainted with a number of prominent scientists of the day, including Charles Darwin, who lived just down the street from them. And it was likely through these networks that she was introduced to Berkeley, who she corresponded with extensively from at least 1843. And these letters can be found in the archives of the Natural History Museum in London. And while their correspondence primarily deals with issues of identification and exchange of specimens, it also gives insight into the production of British mycology, as well as the conflict between Hussey's domestic responsibilities as a clergyman's wife and a mother, and her mycological work. In an undated letter, she says, "I'm, however, beside my legitimate duties as a mother and mistress, the gardener, the farmer, and just now upholsterer. I'm always under the uncomfortable impression that the thing I'm doing is not the right thing to be doing. I never set my palate for oils that some bewitching rarity of the fungus tribe does not come to say, if you do not take my portrait now, you'll never see me again. The same year that Hussey brought the first parts of British mycology to publication, she also provided, uncredited, the illustrations for her friend Charles David Badham's treatise on the esculent funguses of England, a very short work chronicling about 40 different species of esculent fungi. And in the introduction, Badham notes that while rich in esculent funguses, England is the only country in Europe where this important and savory food is from ignorance or prejudice left to perish ungathered. Still, there was the need of a much broader work, popular work. Illustrations of British mycology containing figures and descriptions of the funguses of interest and novelty indigenous to Britain consists of 2 series published in parts from 1847 and 1855, consisting of 90 and 50 plates respectively, illustrated by Hussey and her sister Frances Reed. And while Hussey references other mycologists, particularly the English Flora of Berkeley, for the taxonomic information, much of the field work, the observations, the anecdotes, experiments, often gastronomic, are almost entirely hers and Fanny's. As a popular work for non-botanists, Hussey began the introduction with a brief explanation on the arrangement and general characteristics of the fungi, the necessary tools and steps to collect them, and how one would analyze the contents of your basket once you've finished your collecting trip. And she makes clear that the work is aimed at the student and the amateur, but she hopes it'll please the seasoned mycologist as well, though it's intended to be illustrative rather than an overview of the entire kingdom. And each section begins with a plate, like this one here, followed by taxonomic information, and finally a commentary that ranges from a more detailed evaluation of the species, recipes. I highly recommend her recipe for omelet of giant puffball, allusions to literature and folklore. So you can see at the end of this particular commentary, she's included one of her own poems, which are found throughout the work, and many moral directives to study nature. Every object in nature that induces us to study nature's works is useful. That is an end for its existence, were there no other, and perhaps there is none, that suffices. Hussey frequently touches on the negative attitude towards fungi and the necessity in differentiating between them. There's little fear of English folk committing any rashness in respect to funguses as an article of food, but it will assist discrimination if the decidedly dangerous are known as well as the decidedly safe. Besides, is it not the duty of a mycologist to warn against involuntary emetics as well as recommend dainty stews? She appears to feel somewhat pessimistic about the prospect of inspiring the study of mycology. It is astonishing that while in proportion to the number of known funguses, Great Britain is extremely rich. In students of them, she's hitherto fallen sadly behind. That to inspire a more general taste for this branch of botany is apparently a hopeless task. Much of the work is also very reflective of Hussey's role as a wife and a mother. In her correspondence with Berkeley and in the work, she mentions her children acting as her mycological assistants. Accompanying this plate of Polyporus hispidus, Hussey addresses mothers of young children directly, inducing them to allow their children, particularly girls, to explore nature lest they become vapid, unamusable, delicate, repining, and should cause constant uneasiness and anxiety. The combination of such detailed plates depicting the various fungi, whether they be esculent, inedible but harmless, or poisonous, in multiple states of age, showing multiple angles and sections, with a text that expands on all the necessary details, which, due to the minute differences between species or even between the same fungus, explains the need for such specific attention to detail to avoid misidentification and poisoning your family. Combined with a relaxed commentary, sets Hussey's work apart from the existing British mycological works and sets a framework by which non-botanists can become more comfortable with fungi. To achieve plates of sufficient detail was difficult, and the production of British mycology had frequent problems. In letters to Berkeley from April of 1846, Hussey says that she's been painting fungi for 8 hours that day, and later in August, "I'm so tired of collecting and painting them. I dream of them all night as well as work all day, and it grieves me to see many decay which I must neglect." And throughout the correspondence with Berkeley, she laments the quality of the plates, telling him in a letter from May of 1847 that she dislikes them with an intense disgust, where they should make pores, they make smudges, and that lithography doesn't suit her plates requiring great exactness. The sections of the portrayed fungi so essential to identification was something Hussey had to push for. In an undated letter to Berkeley, she says that her publisher, Lovell Reeve, hates the sections as spoiling the artistic effect of the plates, but surely in Agarics they are absolutely useful. Problems with Reeve led her to threaten that she would not publish another series under his auspices, though she did indeed proceed with the second series under him. And she says that her desire would be to daguerreotype all the fungi. And despite her opinion of the plates, the work was incredibly well received by contemporary reviewers, with much of the praise being directed towards the illustrations. A review in the Annals and Magazine of Natural History says that Illustrations of British Mycology bids fair to be one of the most important that's ever appeared on the useful and noxious fungi, and that of the original drawings of Mrs. Hussey and her sister, it is impossible to speak too highly, and are so characteristic that it is impossible not at once to recognize the species. An essay in the Eclectic Review mentions that Hussey's illustrations, commending them for scientific accuracy, delicacy of coloring, and artistic elegance of arrangement, we are acquainted with few illustrated works in botany which will bear comparison with them. The cost of the work, nearly £8 for the complete first series, which would be about £700 today, an astronomical sum at the time, made it inaccessible for most. A later review of M.C. Cook's 1886 work, Illustrations of British Fungi, mentions Hussey as standing in first rank of excellence alongside Bolton, Sowerby, and Greville, but says that while the figures in British mycology display great artistic merit and the descriptions show considerable care in giving details, the work is more suggestive of the drawing room than the study. Did the publication of the treatise and Illustrations of British Mycology vanquish the fear of fungi? It's difficult to quantify, but I would be remiss to not point out that mushrooming is becoming more and more popular. She's scarcely mentioned in the following works of mycology, although after her, there were numerous popular works of British mycology by many, including Berkeley himself. In an undated letter to Berkeley, Hussey says that after being asked how much she knows of mycology, she says she knows very little. At any rate, I can hold out a hand to guide in the shallow water if I cannot venture into the swell of the Atlantic. I can paint, that I am sure of. Ultimately, although she did not view herself as being particularly knowledgeable about mycology, her desire to change the attitude towards fungi through science and art was apparent. Hussey died in 1853 before the final parts of British mycology could be finished. The final plate, seen here, was completed by her friend Miles Berkeley. Thank you.
Thank you, Kelsey. That was a very interesting window into the life of Anna Maria Hussey. I think that I understand why it's one of your favorites. I like the idea of having a recipe in each one of the descriptions. That's kind of like unique. Last, we're gonna hear from Robert McCracken Peck. He's a senior fellow at the Academy. He's a writer, naturalist, and historian who has traveled extensively in North America and South America, Africa, Asia, and Europe. Bob serves as the humanist on the staff at the Academy. He's gonna be talking about Exsiccatae, xylotheks, and lepidochromes, illustrating nature with itself.
Thank you. Good afternoon, everyone. Thank you for staying to the very end, the bitter end, although we still have wonderful things to come. A tour of some of our own books upstairs, a reception in an exhibition hall, and then a terrific keynote address later. So I hope you'll stay for the rest of the evening. Although there have almost certainly been more books on natural history published in the 21st century than at any other time in history, we still tend to think of the late 18th and 19th centuries as the golden age of natural history publication. James Bateman and John James Audubon took their publications to the extremes of both size and beauty, while Maria Sibylla Merriam, one of my favorites, Mark Catesby, Joseph Bloch, John Gould, Pierre-Joseph Regité, and other naturalist artists bedazzled their contemporaries with illustrations that are still referenced by scientists and sought after by collectors today. The goal in all of these publications was to record and disseminate information about plants and wildlife, and to provide the most lifelike illustrations of the world's flora and fauna. A few publications went further, replicating nature in a more tangible way by incorporating the organisms themselves in their pages, or in the case of trees, using the very subjects being discussed to create the books describing them. But more on that in a moment. The insect books made in this way are probably the ones that catch our eyes the first. In the late 19th century and in the first few years of the 20th, two entomologists, one in the United States and one in Japan, used parallel techniques to illustrate moths and butterflies by attaching the actual scales from their wings to pages on which the bodies of the insects had been printed or painted in advance. In the US, it was Sherman Denton who in 1900 published As Nature Shows Them, Moths and Butterflies of the United States East of the Rocky Mountains. In Japan, it was Yasushi Nawa, founder of the Nawa Insect Museum in Gifu, who published the pressed specimens of butterflies and moths between 1809 and 1912. I'm sorry, 1908 and 1912. Nawa's book, of which only a handful were ever made, is in 2 volumes. They were made up of individual printed cards with the moths and butterfly wings inserted. These were then attached to the paper pages of pre-bound albums, and you can see 3 such cards here. And here is another plate from Nawa's book. Denton's work was published in 3 volumes and had a much larger edition run of close to 500. It included photographic reproductions in black and white and much more text than Nawa's. By coating each page surface with a thin layer of glue made from gum arabic, tragacanth, and fish bladder, then transferring the butterfly wing scales onto it, both Nawa and Denton were able to preserve the structural iridescence of the wings of their subjects in a way that printing ink and hand coloring could not achieve. In the preface to his book, Denton described both his techniques and the extent of his labors as he traveled widely in search of specimens. The colored plates or nature prints used in the work, he explained, are direct transfers from the insects themselves. I have had to make over 50,000 of these transfers for the entire edition, not being able to get anyone else to help me who would do the work as I desired it done. The concept of using actual specimens as illustrations can be traced back to the inventor of sotobosco painting, the Dutch artist Otto Marseus van Schreck, who created many forest still lifes focusing on the microcosms of the forest floor. When he wanted to include butterflies and moths in the paintings, Van Schreck would transfer their scales directly onto the canvas, a conservation and painting technique called lepidochromy. Between 1900 and 1912, this technique was used by the Caribbean naturalist Theo Raymond. While it is almost unknown to the general public or outside of Venezuela, Raymond's work is revered by entomologists for its beauty, precision, and accuracy. Since the 18th century, botanists around the world have traditionally preserved plant specimens by pressing and drying them, then sewing, gluing, or taping them onto individual sheets of paper to be stored in cabinets. As Allison explained in her presentation just a short while ago, collections made in this way are commonly known as herbaria. Of course, most botanists have relied on artists to illustrate their publications, but a few ambitious botanists have distributed herbarium sheets with their work. Even fewer have incorporated the preserved plants in hardbound typeset publications. The latter are known as Exsiccatae. The oldest example of this technique survives in a book made in 1732 by the German naturalist and pharmacist Johann Erhard. And I'm sorry that I don't have a picture of that to show you. There were a few other such books published in the 18th century, but most of the surviving Exsiccatae were created in the 19th century. Among the most beautiful of these is Treasures of the Deep, or Specimens of Scottish Seaweed. It was created in 1847 by a clergyman named David Lansborough. And unlike the personal albums that Julia shared with us earlier, these were published for distribution to others. There are fewer than a dozen copies of this book in existence, 6 in public libraries in the United Kingdom, and even fewer in the United States, including one here at the Academy of Natural Sciences. Although all have at least 12 pages with 32 printed labels, some contain as many as 45 specimens, with these additional plants identified with handwritten labels. The book had a printed title page and printed specimen labels, but no text per se. And here is one more page from Landsborough's book. The author's more widely distributed popular history of British seaweeds was illustrated in the traditional way with lithographic prints, not specimens. It went through 3 editions from 1849 to 1857. In 1850, just a year after Landsborough's Exsiccatae on seaweed and algae appeared, a very similar book was created by an amateur American naturalist named Charles Durant. His book has 43 pages of printed text and another 40 containing specimens of algae from New York Harbor, artfully arranged and mounted on individual cards, 4 to 8 species per page, as you can see here. The book had an ambitious print run of 50 copies. Quite apart from the years of study that enabled Durant to describe the seaweeds in an accurate way, the book he called Algology took more than 2,000 hours of labor, collecting, sorting, identifying, and mounting the specimens. He estimated that he had made over 1,000 miles of perambulations on the seashore to create his life's work. Another mid-19th century Exsiccatae with limited distribution is William Gardner's 20 Lessons on British Mosses. There were multiple editions of this book published between 1846 and 1852. The idea of illustrating the subject with real specimens instead of engravings is not a new one, wrote the author in his preface, but it must be allowed to be more effective, for the works of nature are always superior to the imitations of art, and the eye can more readily recognize a plant in the growing state by this means than by the most careful delineations of the pencil. Trees can be documented in a variety of ways, but one of the most ingenious is by turning the wood into a 3-dimensional record of itself. A small number of such libraries, known as xylotheks, were produced in Europe in the 18th and early 19th centuries. The first and most comprehensive of these was created between 1771 and 1779 by Carl Schildbach, a German naturalist who worked as the manager of a menagerie on an estate in central Germany. Although he lacked a formal education, Schildbach created one of the most remarkable wooden libraries ever produced. Focused entirely on trees, it consists of 546 boxes of various sizes, styled to resemble books. And I'm showing just a small sample of them here. The size of each volume was determined by the relative size of the trees being discussed and the durability of the wood used in its construction. This resulted in wooden books made in folio, octavo, and duodecimo formats. The spine of each book was made from the bark of the relevant tree. This was labeled with a leather band with the tree's Latin name, its common name in German, and its Linnaean classification number. As useful as these books are in identifying trees, their contents hold even more information, which is also conveyed in 3-dimensional form. The front cover of each book opens to reveal a chamber in which various specimens document the tree in its different stages of life. These include twigs, dried leaves, seeds, fruit, both dried and made of wax, and handwritten descriptions of the trees, discussing their many attributes and lifestyles. The Shieldbach Library represents 120 genera and 441 species of trees, most of which grew on the properties for which the book's creator had managerial responsibilities. In 1788, Shieldbach printed a pamphlet to accompany his handiwork. Other examples of such wooden libraries can be found in the Lilienfeld Abbey, a Cistercian monastery in Austria, at the Kremsmünster Abbey, also in Austria, the Strahov Monastery in Prague, and the House of Lobkowitz in the Czech Republic. A list created in 1997 identified 44 extant wood libraries in Europe, though a few more have been found since. My own research on this topic has so far turned up no examples in North America. Other books containing, but not made from original wood samples, were published by a number of authors in the 19th and 20th centuries. The best known of these is by the American botanist Roman Beck Huff. These had larger print runs than the one-off xylotheks, but were no less time-consuming to create. Huff's book, The American Woods, was published in 13 volumes between 1888 and 1913. It offers a collection of paper-thin cross-sectional slices of wood using a machine that Huff himself had patented. To each tree, he dedicated a cardboard sheet in which was embedded 3 slices, transverse, radial, and tangential sections of the wood. These were accompanied by a text about the botany, habitat, and medicinal and commercial uses of the tree species represented. In total, each of the volumes contained at least 25 plates, and the complete 14-volume collection comprises 1,056 slices, representing 354 tree species. American Woods received a grand prize in the 1889 Arce Exposition and gold medals at the Columbian, Pan American, Louisiana Purchase, and Alaska Yukon expositions. For antiquarian book collectors, American Woods is one of the most sought-after natural history publications of the 20th century. In 2000, the art auction house of Christie's sold a complete set for $92,100. Given the amount of time and effort required to create any of the specimen-based collections I've described today, and the world's current sensitivity to the loss of biodiversity, it's unlikely that any comparable things will be made in the years to come. We can only marvel at the devotion to science and art that resulted in these remarkable artifacts. If I had more time, I'd love to tell you about ornithological books illustrated with real bird feathers, but that topic will have to wait for another day. For now, I will simply conclude by reminding you of the names of the 3 techniques of preservation, illustration, and publication about which I've spoken today, words you probably haven't used a lot in daily conversations. Xylotheks, or wooden books on trees made from the trees themselves. Lepidochromes, or books on moths and butterflies using the real insect wings as illustrations. And Exsiccatae, the books that used pressed plant specimens in lieu of engraved illustrations. And I look forward to showing you a few of these from the Academy's collection as we gather together in the library upstairs at the end of this session. Thank you.
Well, first of all, thank you all for your presentations. They were very illuminating in many ways. And I think not just the afternoon session, but in general, the day has brought a light of different perspectives that sometimes you don't even think about when you work specifically in the science behind the collections. So I'm really thankful for the entire day. And I think before opening for questions, I think there is a lot of commonalities in what was discussed today in terms of how there is so many layers to these collections and everything that could be brought up to the light in terms of the people who was involved in the work, the methodologies that are used, and how we see a reflection of like the times and how the inequalities, the gender inequality. So I want to kind of hear of each one of you a little more of that perspective of histories and layers that all of these materials can give us into like a view into the past, and how do you see that moving forward since we're still collecting currently? I don't know if that's too if anybody feels like
Well, I should start in that I have the good fortune to work here at the Academy, and my colleagues are out collecting all the time. Collections are really at the base of the work that goes on in science, as you know. And it's institutions like this that are able to preserve these specimens essentially in perpetuity. If they're well handled, kept out of light, kept with temperature and humidity control and so on, these things can go on for hundreds, we hope many hundreds of years, and therefore not have to be collected again and again. It's the stability of that material that's important. When they get illustrated in books with engravings and so on, that's one way to convey the information. But I think everyone will agree that the specimens themselves are often at the base, and why they're so important for preservation. Further thoughts from anyone else?
Yeah, I mean, thinking about illustrations of British mycology and Anna Maria Hussey, I kind of discovered the book just like walking through the stacks one day, which is, I'm blessed every day to get to walk through and just look at all these amazing books. And I just looked at the spine, and it jumped out to me, and I loved the illustrations. And then reading it, found it to be such an enriching sort of experience, and like the passion for her subject kind of jumped off the page. And the one thing I think about most frequently now that I am a somewhat new mother is the kind of, especially reading the correspondence that she had, the sort of difficulty she had in balancing that role as a mother, and the other responsibilities that she had, domestic responsibilities that she had with doing science. And I mean, I would be remiss to not note that, you know, the family employed several servants, they had a governess, they had domestic labor who would help with the children when she was able to do her mycology in the same way that my son is at daycare right now. Or I hope he got picked up right now. I think it's after 5 o'clock.
Only at home.
I'll have to check with his dad. You know, enables me to come here and do this work every day. And I know that still, I, you know, every day speak with mothers who work here at the Academy who are in the field doing science, and that some of the difficulties that come with that, you know, are still present today. They were present in 1847, they're present now.
And a lot of the, not just in that sense, but a lot of the inequalities that you probably highlighted in your talks are still like existent, and how I feel like we even owe to the people through all of these studies to bring back to light information and to illuminate onto what was going on and how can we change for the future, if you may. But
yeah, I guess one issue that sort of has come to mind is around access. And you know, the Academy, just a thank you to Dr. Kelsey Smith, who's the collections manager of the Librarian. She's sort of facilitated that access to this, you know, odd collection, right? It talk about fragments of fragments. Like I think sort of the work on collections and decolonial approaches to collections means sort of making visible these collections, even if it's not clear what to do. You know, our impulse with some of these seed collections might be to maybe see if they could be germinated, right? But is that, would that itself sort of repeat certain colonial practices? Our impulse also might be rematriation of seeds, but I know just from reading and conversations I've had, once seeds enter institutional collections for some Indigenous groups, they are considered to have, you know, they were taken from the community, and they sort of, in some sense, you know, they're being preserved in these institutional repositories, but rematriation would only be done right in dialogue with and at the request of Indigenous groups. So I think when you have objects that are potentially, you know, could change their form again, like seeds, I think those conversations are really, really important. And, you know, as an archival researcher, I'm quite conscious when I handle these objects to sort of, yeah, I mean, I use that word beings deliberately instead of just objects or specimens.
I think that the collection of natural history specimens, the survival of natural history collections offers a unique window into these very challenging periods of our history that they represent, the same way that obviously we're not asking our intellectual and scientific and scholarly questions in a vacuum. Neither were these objects collected or saved or analyzed in a vacuum, and in that sense they offer a unique opportunity, unique window to get to parts of past civilizations and cultures and peoples that otherwise might not be available to us, even when they're collected in a colonial context.
Thank you. I would like to open it for questions.
Thank you very much for your research and sharing your knowledge with us. Really appreciate that. I kind of heard that in collecting specimens and in each of your topics, it's difficult, preservation and historic and availability. So given our current, you know, technology and the availability of all the data, do you find it easier for, you know, what you do, or do you find it maybe daunting because of the availability of so much data? And what do you keep and what don't you keep?
I don't know. I could start with that. That's a really great question. Most of the materials I work on have not been digitized, and in part due to their fragility or just resources, right? Collections, but I think there's quite an extensive literature now by librarians and archivists on the carbon footprint of digitization itself. So Ira Tansey is one name, Benjamin Goldman is another name. So archivists are really writing about that carbon footprint, because when something is digitized, then, you know, you use a handheld device often, you know, to consult it. The data is stored, cooling, you know, data centers. Like there's such a heavy carbon that I think that it makes that question of access and digitization of these unique materials. You know, this is something Sarah Werner, the book historian, has said, you know, is digitization preservation? Not always, or does that preservation come at a cost to the climate?
I just agree with you. I think there are two sides to the digitization effort. And we have some equipment here that can do three-dimensional scans of fossils and skulls and so on. Yes, it does use a lot of energy. On the other hand, it saves a huge carbon footprint of people coming all the way here to see it. If somebody's trying to study something and they're in Europe or Japan or elsewhere, and they've got to come and spend 3 days here, we would rather send them the digital image. And if they can get enough from that, we think we've helped save a little bit of the degradation of the world.
And sometimes even like when material is sent, so you're risking maybe the materials that you're sending and the carbon footprint of sending it to. So yeah, I think that it's opening more doors, and that will be my 2 cents. I don't know if anybody else wants to answer the question or.
we move on to some other questions. So then I think that I will welcome everybody to go to the Dietrich gallery. There is a reading room adjacent to it, and then you will see materials that were discussed during from the studies that they presented.
Yeah, so just Franklin asked me up. Well, thanks everyone. This has been an
Yeah.
amazing day. So thank you so much to all the speakers, to the audience, to those who are following us online, to my fellow moderators. What a nice way of spending an afternoon at work. This has been excellent.